Hello everyone. This is a video to show you some of the functionalities in the Excalibur software. As you could see, you can download it either from the Lightwiz software website or from the website expertsinuncertainty.net. And once you have downloaded and installed it, you can open the application. Now here is the empty window. In order to enter expert data, we have a new case, and we see that we have the realization data to fill in. These are the questions that the experts had to assess. So let's use the Dutch eating habits example, where we had 5 calibration questions and 2 questions of interest, for which we had the assessments of 3 experts. So we have now to enter the questions. So that's question 1. We can use the ID, and then we have the realization, and that was 50 for this question. We can also enter the name, so that is what percentage of the Dutch, and then filling in the entire question. Well, we can do that for all the questions, but that will cost some time, so we'll skip it for now. We have the second question, which is has the realization 7. Then we have question number 3, which has the realization 108. And then we have question 4, which has a realization 66. And we have the last calibration question, which has the realization 24. We also have 2 questions of interest, right? That was question number 6. Well, no realization available here, so we leave it as it is, and Q7. Now, this scale refers to the background measure, and if you recall from the previous videos, there is either a uniform or a log uniform background measure. Now, we are going to use only uniform, and an easy way, instead of typing uni all the time, is just to change all scales to uni. And if you remember this background, it referred to basically which background measure to use. And I mentioned during the video that it's just going to be the uniform. And the reason in this particular example is that we have basically assessments within the same order of magnitude. We don't have assessments that would go from 5 to 5,000 to 5 million. So for more orders of magnitude, then it would be more appropriate to use the log uniform background measure. Okay, now we have the questions. We need to enter expert data, so we hit experts here. And first, before getting to the expert data, we need to inform Excalibur how many quantiles did the experts assess. The typical is 3, that we also had in our Dutch eating habits example, but Excalibur also allows for 4 or 5. Okay, 3 it is, and now we go and we need to fill in the expert information. So the ID is Q1, and we can fill in also expert 1 name, full name, or expert 2 full name, but we're going to keep the ID for now. And I don't have 4 experts, so I'm going to select this and just delete the expert row, and then this is what remains, the 3 experts. Now, when I double click on this, I have the entire window with the assessments for the expert 1. So we have the quantiles here that will need to be filled in. That's 46, and 49, and 9, and 12, and 15. Well, that might take a while to fill in all the assessments for the 3 experts. We can save the case now, or save as, and we see that there's a file, a DTT file, which comes out. So we can have an exercise 1 and save it for later. What I'm going to do now is I'm going to open already written DTT file with all the experts assessments. So I have all of them written here. For expert 2 the same, and expert 3 again the assessments. Okay, now it's time to see Excalibur at work. So we have the calculate window, and we see that in this calculate window we can have a menu to select from, and then the first one is the weight menu. So we have 4 possibilities. First is this global. The global means that is performance-based weights that are going to be used. And equal means equal weights, and item refers to a different kind of performance-based weights, which take into account not the overall information score, so this global information score, remember that was an average of all the information scores for each of the calibration questions, but take the information score per calibration question. So for each calibration question, I have an information score for an expert together with the overall or this global calibration score, and I can get a combined score for each calibration question. So for each item, I can get an item weight. So that's also an option. And there is also user, where basically the analyst pre-specifies the weights that each expert would get. Now this with the chi-square and information score, it's something purely for the Excalibur. I suggest you leave it as it is. The optimization here refers to either the fact that with a global or with the item, an optimized procedure of selecting the set of experts can be carried on, and again with the evaluation of the overall performance of the combined score of the resulting decision maker. Bayesian updates and discrepancy we're going to skip for now. Intrinsic range, this is the K. The K overshoot here, 0.1, which can be set either with whatever value from 0.01 to 100. And the calibration power, we're not going to deal with it. It's just when comparing calibration scores of experts who answer different number of calibration questions. But again, that's not something which we'll work with now. So let's see the classical model at work. We have the global weights, and we have, well, let's start with the equal weights. Yeah, we have the equal weight decision maker, and then I type in a name for me later on to remember, and then I hit run. So now I see the results of scoring experts. So not only the equal weights, but the results for all 3 experts. We have the calibration score here on the first column. Now the second and the third columns are information scores. Now the third one is an information score for all the calibration questions. So the one that you have computed in module 2. And this one refers to the information score, including all the questions. So both the calibration questions and the questions of interest. And you see some differences, and it basically reflects the differences in the information of the experts between the calibration questions and the questions of interest. Now, the unnormalized weight refers basically to the combined score, so the product between the calibration score and the information score, so the first and the third column. And you might remember them from module 3. And here it's a weight. Well, we have just performed an equal-based decision maker. So we have, well, assigning equal weight to all 3 experts. We also have the possibility to include the decision maker in the pool of experts. And that's something which can be reflected better in taking the performance-based decision maker later on. So we also have the performance of the equal-based decision maker. So we have the calibration score, quite good, together with the information score, which is a bit low. So definitely much lower than any of the experts. So we see that it loses a lot on the information. Of course, the more uninformative, the higher the chance that it becomes statistically accurate. So yeah, these two make sense. Now let's have a look and recall the results with a performance-based decision maker. So I'm going to give it a name here, and then I'm going to have run. So a decrease in the calibration score, that's already we've seen in module 3, and also a bit in the information score. So we have that performance for this particular example. Now if we hit the optimization, let's see what happens. We have the performance-based decision maker and with the optimization procedure, and we hit run. Now we see an improvement with respect to the performance-based decision, so it's optimized with respect to the calibration score. It has also optimized with the with respect to the information score, but we actually see that the weight is given only to expert 2. And indeed, it leads to the highest combined score of all the 3 decision makers. Now, this is for the global. We could choose also the item. So we have the item and then choose first without the optimization. And then we see again results comparing the calibration and the information score. And we could also choose to have the performance-based decision maker with the item and then also to perform the optimization. And then we also have other exercises, other results here. So we can combine in 5 different ways the expert assessments, with or without the optimization, with or without taking into account performance. And this results in decision makers which can be evaluated based on the calibration and information score or the overall performance. And we can also use that, of course, that's also the main idea, to show, well, how to aggregate those and how to answer questions of interest. So this is done with a solution. So pressing here solution, and the last one that we have looked is this item with optimization, and we have here the assessments of this decision maker. So we have, and it's here the item with optimization. Yeah, so weights item and optimization. And here are the solution of this decision maker. So answers for all the calibration questions and also for the questions of interest. Well, you can see that nothing spectacular is here because it's probably the optimize which takes into account the weight for the second expert fully. So if we were to look at the solution, so now we can reset and then go back and calculate only the global, so no optimization, and run. And you see here, I forgot to mention, we have the, this is the combined score, and from multiplying the column 2 or 3, and this is the weight. So this is the normalized weights, and it's without the decision maker because it's just normalized for the 3 experts here. Now, if we take a look at the solution, we have what the performance-based decision maker would have answered to the 5 calibration questions, but also to the questions of interest. So we would have the combined assessments using the performance-based weights. Now, quite quickly, I have to wrap up. I have here some other options. I have a graph. So there are graphs that you can have a look either by expert, all the assessments for the 5 calibration questions, and then all of them. Probably more interesting is to have a look per question. So to have a look of all the 3 experts, and then here is just the performance-based decision maker, but to combine all of them. And you can have the expert scores as well. And yeah, I think this will has covered the, let's say, the basic notions. Okay. I hope now things are clear with Excalibur. Enjoy working with it, and looking forward to hearing your feedback, questions, or comments.